The first one we haven't talked about yet outside of class is number 3. There's a new formula for number 3, and questions like number 3 and 4, if they appear on the quiz tomorrow, they will be bonus because I'm showing you this pretty simple formula right now. S equals radius times theta, which is the angle. So what that really means is the arc length equals the radius times the angle. And it has to be in radians, that angle. So the arc length they gave us in this problem was 7 pi over 9. So the arc length equals that, the radius of 2 times the angle. So to solve for the angle, you just have to divide both sides of the equation by 2. When you divide by 2, since it's a fraction, I like to make it 2 over 1. So this simplifies to 7 pi over 9 times 1 over 2, because instead of dividing by 2 over 1, you multiply by 1 over 2. On the top, we have 7 pi. On the bottom, we have 18. The central angle is 7 pi over 18 radians. And this is your new formula. S equals r theta. The arc length equals the radius times the angle in radians. So the same formula here, we're talking about arc length, so it's S equals r theta. The arc length equals the radius times the angle in radians. This time you're looking for the arc length. So what is S? If we know that the radius is 12 and the central angle is 5 pi over 4. So all we have to do is multiply 12 by 5 pi over 4, and that is 60 pi over 4, which reduces to 15 pi. And it's a length, so it's 15 pi centimeters, which sounds weird, but that's the answer because we're talking about the length of the arc, and it has to be in a distance measure like centimeters. So I rewrote the 300 and the 12 because it's hard to read on my paper, probably easier to see on yours. There's a major arc formed by an angle of 300 degrees along the outside there. So we have a 300-degree angle. We have a radius of 12, and it wants us to find the area of the sector. So we want the darkened pieces of pizza rather than the white piece. We want everything else except for that white piece. So it is 300 out of 360ths of the pizza. And we're talking area, so it's pi r squared. And I won't completely finish it for you, but if you type that into your calculator and you use parentheses, it should be in the 370s square centimeters, because we're talking about area. This one is a very tiny sliver. We're looking for the area again, and the area is 15 360ths of pi r squared. Again, I won't show the rest of the work because I want you to enter this on your own using parentheses, but you should get a number between 18 and 19 square centimeters. All 3 classes didn't get to letter C on Friday in class, so we'll take a look at it right now. So we're looking at question C over here on the right. One radius is 4, one radius is 5. They happen to be tangent to each other, so we know that if you're going to move circle A onto circle B, that means we must want to go left. Take that big circle and move it to the left exactly 9 spaces to the left, which is a translation of -9, 0. So I took the big circle because it told me to start with A and move it on to circle B, -9, 0. Now the reason I have 4/5 as the scale factor to dilate by is because I'm going from big to small, so I need to get smaller. So the image, the new one, is 4. The pre-image, the old one, is 5. 4 over 5. Number 9 is a pretty important question. It says, circle A has a radius of 3 and circle B has a radius of 7. Use transformations to explain why circle A is similar to circle B. Well, first of all circles are always similar because there's no other shape to a round thing. They're all round. So because you could start off by saying all circles are similar because using a translation and a dilation, you can map one onto the other. A translation and a dilation are similarity transformations. So just like we did up here in all three of those problems, all circles are similar because you can translate and then dilate and map one right onto the other, which makes them similar because we use nothing other than translations and dilations, which are similarity transformations. There's 4 different things to find here. You can see I already wrote a 57 here. Where did that come from? Well, those 2 angles have to add up to 180. So I knew that the other side was 57. Now, if that is 57 and it's a central angle to this arc, and that arc is broken up into 2, then both of those arcs, A to F and F to E, would both be half of 57, which is 28.5. That's one of the questions. A to F, that arc is 28.5. It's almost like there's a central angle cut in the middle there, and they're both half of 57. BC is this arc at the top. Well, if that's 57, so is that, because they're vertical angles. That's one way to look at it, which means a central angle of 57 leads to an arc of 57. Letter B says the measure of BFD. Measure of B to F to D. B to F to D means you have to start at B and go through F to get to D. So it's that major arc from B all the way around, using F as like not a midpoint, but a point somewhere in the middle you have to pass through to get to D. So B to F to D is basically the entire circle, 360, minus this arc of 57 that we already found out about, minus this arc of 28.5, because if you notice, it has that same congruence marking that we had at the bottom. So that's got to be equal too. So if you take 360 and you take away 57 and 28.5, you have the arc for BFD, which is 274.5 degrees. And mark arc D to E is this arc right here. Make it a little darker, easier to see. That's D to E, which is 123 take away 28.5. And that's because if this is 123, so is that, but you want to eliminate that 28.5. So it's 123 minus 28.5, which is 94.5 degrees. Sometimes I like to fill out whatever I can fill out without even looking at the questions first, because sometimes you'll answer them automatically. If that's 32, well, that central angle is 32 then. Another thing I noticed is that we have a diameter going through the middle here, which means this whole angle is 180. So I can figure out this one by taking 180 and subtracting 43 and 32, and that leaves me with 105 degrees here and 105 degrees there, because those are vertical. 105 is supplementary with 75 on that side. So I haven't even looked at the questions yet, but I know that I have that much information. Let's see if I've answered anything yet. Arc FA is right here. That's 105 degrees because it comes from that central angle of 105 right there. Angle BGC is from B to the center to here. Well, we already answered that. That's 32 degrees because it comes from the arc on the outside. The measure of arc AFD starts here, comes all the way around F, and goes all the way to D. The way I see this one, angle AFD, is you could add up the 105, the 75, and another 105, and then just subtract this piece here, which is the same as this, which is 43. So essentially we're going to go 105 and 75, another 105, figure out what that is, and then we're going to subtract the 43, and that will give me the arc which stops at D, which would be 242 degrees. The last piece is the measure of angle FGE. FGE is this angle right here, which we already knew. See, it came from the beginning when we just started filling things out. We already knew that that was 75 because it was supplementary with the 105 next to it. Won't talk too much through number 11, but we have a diameter here, which means we have a 180 there, which means that this has to be 110. And if that's 110, then the inscribed angle that it comes from is half of that. Now angle 2 comes from this arc because it opens up like that. This is 110 because it's the same vertical angle there, which means that this is also 55. We have a central angle here, so that arc is exactly the same, 66. We have an inscribed angle coming from that same arc, so that would be 33. We have to find this a little bit more indirectly. 34 opens up its inscribed angle to an arc of 68. 56 opens up to an inscribed, the inscribed angle opens up to an arc of 112, which means if I have this 112, that comes from that angle back here. So angle 1 is going to be half of 112, which happens to be that same 56. And angle 2, I kind of sketched it over here quickly, is that Goldilocks situation where we have two chords that meet. 68 is too low, 112 is too high, so you add them up and divide by 2. So we know that pretty much pretty quickly right there. 114 is the arc, so the central angle is 114, which would be supplementary next to it with 66. Angle 2 comes from this arc here, and it would be half of that arc when we figure out what that blue arc is. You notice we have a diameter going right down the middle here, which means all of that is 180. So 180 minus the 114 that we have existing leaves us with 66 degrees right here, which means that would be 33. Because a quadrilateral has to add up to 360, and because it's inscribed in a circle, there's a shortcut here that the opposite angles will always add up to 180. The opposite angles will always add up to 180, because as one gets bigger, the other one has to get smaller, and if you inscribe it in a circle, it locks in. So the two pinks have to be 180, and the two blues have to be 180. Okay, right away we see the right angle, so there's one on the opposite side also. 65 and 25 are complementary, so that has to be a 25-degree angle, and since it's from the center, DE is a 25-degree arc. Angle AFE is this arc right here, or that angle which leads to the same arc out here. Because we have a diameter going through the middle there, 180 minus 25 will be this answer right here. Arc E to A to C is 3/4 of the circle, minus that 190-degree chunk. And arc AC is 90 degrees plus this little piece here. And that little piece would be 25 degrees more since those two are vertical, so it would be 90 and 25 more.